Okay, guys, so this is a continuation from the other day. So this equation is equivalent to summation of forces equals to MA, and this is summation of moments equals to I alpha, but already substitute the alpha in function of X using this expression here. So now basically what I need to do is replace into this equation the T by the T coming from here. Okay, so basically we need to solve for T and C and eliminate the T from these two equations. All right, so let me go to a new page, but let me just rewrite those two equations. Let's see. So page 53, what we'll have, I've just rewrite the same two equations, would be mg minus t minus 2kx minus 3c x dot equal to mx double dot and minus t times r plus 2k rx plus 6c rx dot equal mr over 2x double dot. Okay, so I think the fastest way to do this, doesn't mean it's the easiest. I know you know how to do that. Let me just rewrite, let's just rewrite the two equations in function of t. And see what happens. So let's say over here we write, so the first one will give us what? T will be equal to mg minus 2kx minus 3cx dot minus mx double dot. And from the bottom one, if I divide everything by r, you can find that, for this time, let's say minus t, might be even easier. So divided by r, everything on that expression will give us what? So we give us minus 2kx, this r will go away, minus 6cx dot plus mr over 2 x double dot. No, the r disappears because we divide it, so m divided by 2. Again, you can go and substitute if you want, but I think this is a bit faster. So now what can I do? I can just add these two expressions now together. So the left-hand side will be 0. And then what do we have on the right-hand side? So let's look at these. Let's look at these two over here. What do we get over here? We get, so minus mx plus mx divided by 2. Did I do a sign issue here? Is that correct? So mg, we move this one to there. So that one moves over there. Is that correct here? And then this one, keep that one here. So I want to stay positive. Okay. So if I do it this way, what do we get? We're gonna get over here minus m over 2 x double dot minus 9c x dot and minus 4kx and then we have plus mg. Okay, or we can just say that the equation will be equal to what? Will be equal to m over 2 x double dot plus 9c x dot plus 4kx will be equal to mg. Okay, or I think it's better to write under the form x double dot plus, so this will be, I'm dividing everything by m divided by 2, so this will give us 18 c over m x dot plus 8k over m x, and this will be equal to 2g. Okay, so this will be the equation over here. We can say all right. So the reason I'm rewriting this, where omega sub n will be equal to hk over m. So the term in function of x, this should be what? This is the term giving the natural frequency, no? Yep. So this is omega, this is actually omega n squared, where this is the natural frequency. All right. So what do we know? The above differential equation of motion is non-homogeneous non-homogeneous means what? That the right-hand side is not equal to 0. Okay, that's the meaning of non-homogeneous. So to make it homogeneous, the following change in variable is necessary. And we have done that already like 2 or 3 times. So basically over here, we could say that x, the variable x would be equal to the new variable x plus x equilibrium, okay? Okay, so what is x equilibrium? So what happens at equilibrium? At equilibrium, the system is not moving, no? So what does that mean? It means that x double dot, the acceleration, and the velocity will be 0. System at rest. So in that case, what we have, so equation of motion reduces to what? Hk over mx equilibrium will be equal to 2G. Or this will give us that the X equilibrium is equal to mg divided by 4K. Okay, so what does that mean? That the new variable here so we're gonna have so that we know that X equal to X bar plus X equilibrium will mean that X equal to X bar plus mg over 4K. All right, so if we have this, what does that mean? X dot will be equal to what? This is a constant, so the derivative of this term will be 0, no? So this will be just equal to X bar dot. And then what will happen with X double dot? The same thing, no? Because the derivative of this will be 0. So now we say substituting into, I'm going to rewrite it since I have it on the other page, into X double dot plus 18C over M X dot plus 8K over M X equal to 2G. So this will give us what? Will give us X bar double dot plus 18C over M X bar dot, and this is the one that will change, plus 8K over M, and X will be X bar plus mg divided by 4K equal to 2G. Okay, so over here you see, let's write it down. Maybe you don't see it. So we get X double dot plus 18C over M X bar dot plus 8K over M X bar. And then this term will give us what? The M will cancel out, this K would cancel out, and will give us plus 2G equals to 2G. So what's going to happen is that this term is canceling this one, and we end up with the homogeneous solution. Okay. Okay, so what does that mean? Now we know how to solve the homogeneous solution, no? So we can solve for X bar, and once we have the solution for X bar, what will be X? we just need to add to the solution of x bar at the end the solution for x equilibrium, no? And that way we'll have the full solution, okay? So we know how to solve this equation, all right? So, so the above equation of motion is homogeneous and can be solved following the standard procedure, let's say. So what is the standard procedure? Let's see if you remember that, not maybe from this class. I mean, we did it in this class, but from differential equations. What is the first thing you need to do? Assume the solution. Once you assume the solution, you go and substitute, no? That will give you the characteristic equation. All right? So step one is always assume harmonic solution. Guys, I'm not picky about final results, but I'm picky about procedures. So be careful on the exams and so on. This is what I'm looking for, procedures. Not that much final results. So over here, we already have a C, so maybe let's use another variable. So assume harmonic solution. So we can assume X bar, one of T, should be equal, let's use the letter D, exponential of minus lambda T. So this is the assumed harmonic solution. All right, so I'm gonna go. So, okay, so we have this, let's go once more in details in our space. So X bar dot will be equal to what? Will be equal to minus lambda D, E of minus lambda T, and X bar double dot should be equal to what? It should be lambda squared D E of minus lambda T. So now we can go and substitute these equations here. I'm going to stop rewriting all the equation. Let me just call this one, whatever, star. So now we can go and substitute into the star equation, okay? Into the equation of motion. So step two. Substitute into equation of motion. Let me rewrite it down very quick. So which is x dot plus 18c over m x bar plus 8k over m x bar equal to 0. Okay, so if we substitute, what do we get? We're gonna get lambda squared d e of minus lambda t plus 18c over m of minus lambda d e minus lambda t plus hk over m d of minus lambda t equal to 0. So here I can factor out by what? I'll have d exponential of minus lambda t. And then what we're gonna have? We're gonna have lambda square minus 18 over C times M lambda plus 8 over K M equal to 0. Okay, we have done this already, I think, a couple of times, no? All right, so now what is the next step? When is this equation satisfied? This equation will be satisfied when either this term is 0 or when the term inside the bracket is 0, no? Okay, so the equation is satisfied if and only if, that's what it means of the I and the double F, if and only if. So case 1 is the exponential of minus lambda t is equal to 0. This will be known as the trivial solution, because when is this just valid? When d is equal to 0, no? All right. Or when what? When the term in brackets, or when lambda squared minus 18 C over M lambda plus 8 K over M equal to 0. Okay, so basically what do we need to do? Solve the quadratic equation, no? So solving, let me go to the 9. Solving the quadratic equation, which is this one here. Okay, so I'm sure that you all know how to do it, but I don't want to spend too much time with the algebra, so I might go to Maple very quick. But basically what should be here, so the two roots are what? So lambda 1, 2 will be equal to what? So it should be the minus b, no? Which should be this term, which is 18 C over M. Then we have plus minus the square root of, let's see what. So we have now b squared, so it would be 18 C over M squared minus 4ab, which is 4 times hk over M. All right, divided by 2a, which is just 2. Okay, so what happened is that I don't really like to give values, but if you remember the initial statement of the problem, we were given values for all these quantities, no? For R and so on. So really, you can solve this and give values. But if you give values, I think you lose the procedure, no? Okay, so I'd rather keep the procedure for as long as I can. So I don't have values really on my notes either. So, okay, so we have this expression. So now we can define what is a critical damping. You remember the critical damping is defined as the value of the damping for which this will be equal to 0. Okay, that was the definition. So page 56. This one. All right, so let us define the critical value. So the critical value, the critical damping is, so if we remember, we define the critical damping value as the value for which the term inside the square root was equal to 0. So that means that we have the 18 C over M square minus 4 times HK over M will be equal to 0. So this value over here, this C over here is the C critical, okay? So in that case, you have C equals C critical. Okay, so I'm going to need probably a little bit of help over here. This would be equal to what? 18 squared CC squared divided by M squared would be equal to 32 K over M. So this will give us that the CC critical will be equal to what? 32K divided by 18 squared, and this M will go up. So 32K M Okay, so I think now we're gonna have to start giving values, otherwise it's gonna get way too complicated. And let's see what happens. So let's go back to the initial notes. So the initial problem data was what? Is K equal to 60 Newton meters, C equal to 24 Newton second square per meter. Okay, and M, we don't need a C over here, but we're gonna need it later, and M is equal to 20 kilograms. Okay, so doing the numerical calculation, you will get, so NA stands for numerical application. You find that CC is 10.89. Okay, and next, let's look at the damping ratio. C was defined or is defined as what? It's defined as equal to the damping divided by C sub C. So we have damping ratio here is 24. divided by 10.89. So if you do the calculation, we get 2.2. Okay? So now, if you remember, when we find the solution of the homogeneous of the damped free vibration problem, so we say we have three cases. One was the overdamped, critically damped, and underdamped. No? So this one here, the damping is higher than 1. So in this case, we have damping higher than 1. So we are dealing then with the overdamped case. Okay? So this is an overdamped case. So we could go okay, so let's pause for a second and let's go back to that page. So basically, in order to do some of the calculations, okay, guys, to save some time, I just went to Maple, I put the equations, I put the data, and you have these two roots over here, okay? If you want, I will provide you with this file if you're interested, but we need to find the values for these two values. So let's say lambda 1 will be, I think I already did that one, but let's go here. You can copy it, would be 20.42. So let me go to the notes, and I'm just going to write from Maple/MATLAB. We have that lambda 1 will be equal to 20.45, no, 425. And lambda 2, let me go back over here. Will be equal to 1.175. Okay? So that's what I have over here. So again, if you want, let's do it the hard way, like following the procedure from scratch. So now, step 3, what was step 1? Was to assume the solution, no? So we have 2 lambdas, correct? So now step 3, if you want, we can say find general solution. Which basically just means substitute lambda 1 and lambda 2 into assumed solution, which is x of t was equal to d exponential of minus lambda t. So that means what? That x of, really should be x bar of t for us. So we need to be careful, no? Because I think the assumed solution was x bar of t, no? If I remember right. Because the xt is the x plus the x equilibrium. So it should be equal to a d1 variable 1 exponential of minus lambda 1t plus d2 exponential of minus lambda 2t. Okay? Or we can just say this will be x of t will be equal to d1 exponential of minus 20.425 t plus d2 exponential of minus 1.175 t. Okay, so this is the general solution. Last step, step 4, will be solve the constants d1 and d2 using the initial conditions. So in this problem, what were the two initial conditions we had? So they were in blue, was x at 0 equal to 0 and velocity at 0 equal to 0, no? Okay. So from initial conditions, x at 0 is equal to 0 and x dot at 0 is equal to 0, which is the velocity. Okay, IC stands for initial conditions. So once again, I'm going to pause a little bit and we're going to do this using Maple, okay? And MATLAB if necessary. It will be a lot faster. I mean, we can do it, but I mean, we can set it up if you want, and then we can solve, okay? So the first equation will be what? So in other words, we have two variables, we need two equations, no? So the first equation is what? Is x at t equals 0 equals 0. So what do? We substitute into this equation. Actually here, but the x bar. Okay, it doesn't matter. It should be x bar all right, we need to be careful here. Maybe I forgot to do one step, otherwise it's going to get confusing. All right, so let's scratch this one. Okay, so these boundary conditions are given for x and not for x bar. Okay, so what can we do? So this is the solution for x of t, and we can say that the solution for x of t is given by, what was the assumption that we had before? In order to do the equation homogeneous, we had that x was equal to x bar plus x equilibrium, okay? And x equilibrium was equal to what? mg over 4k. So that means that we have x is equal to x bar plus x equilibrium. So that means that our x of t is equal to d1 exponential of minus 20.425 t plus d2 exponential of minus 1.175 t plus x equilibrium, which is mg over 4k. Okay, maybe it would be easier if we have the value for this, but it doesn't matter. So the first equation would be what? X at time equals 0 equal to 0. So this will give you what? This will give you D1 plus D2, okay, plus mg over 4k will be equal to 0, no? Plus mg over 4k equal to 0. Or I can just rewrite this equation as D1 plus D2 equal to minus mg over 4k. Let's say this will be our equation Roman 1. I'll resume, guys. So again, I think I forgot recording maybe the last couple of minutes. So let me go back to Maple. In Maple, what I did is we have here to solve for the two variables. Okay. I think we did this, no, in the video. I think we did this, but basically what I need to do is the two conditions are defined into these two equations, D1 plus D2, D1 plus D2. You solve these two equations here, equation 1, equation 2 for D1, D2. All right. And now we're going to plot the solution. So what we need to do is replace. So what we did here on the notes, we have D1, D2. This is lambda 1, lambda 2. This is x equilibrium. All right. So we're going to plot this figure. The fastest way to do it is probably with MATLAB. We put on a small code D1. We make the time to vary between 0, the initial condition, and 20 seconds. And we're just talking that the last value over here, what is the last value? This is the equilibrium position. All right. So when we run this, we already run it, but we get this figure where you see the response starts from 0, our initial condition, and then pretty quick, it's not that quick, but let's say within 5 seconds, all the response is damped and the system is going to remain over the equilibrium position. Okay, so we see that makes sense. So I know you can make all this stuff more fancy, but that's it. So again, I hope that helps you to go through the procedure, because again, it's not the material is important, but what's important, more important to me, is that you learn the procedure, how to solve the problem. Okay, so maybe here let's just do a quick figure. So it should be t, this should be x of t. And what we find out from the figure is that more or less at five seconds, this is x equilibrium, which is the 0.8175. Okay, so the solution kind of look this way, okay? Like at about 5 seconds, it looked like all the response is being done, okay, from the figure. We could actually calculate.